Ayun na. Okay, salamat. So, good afternoon class. So, ito yung pangilan na ba to? Second meeting na ba to sa finals, no?
Yes pa.
So, title ng lesson natin ngayon ay effective or root mean square. Dati kasi ano yan, di ba? Yung average power, kung saan in terms of maximum value ng voltage, kaya maximum value ng current na pinag-usapan natin doon. So, this time, in terms of root mean square or in terms of effective value ng voltage kaya or current. Para sabihin natin, ito kukunin natin yung um, average power ng limbawang load natin. So merong binanggit na dalawang circuit dito kung saan compare yung average power absorbed by this resistor. Same resistor ang pinag-uusapan. Kapag daw parehas yung resistor natin, ay yung load natin, halimbawa, parehong resistor, halimbawa sabing ganyan, may binabanggit dito na yung effective value daw ng periodic current natin is equal to the value of the periodic current which is flowing through a resistor, and it delivers the same average power to the resistor as does the periodic current. So, ibig sabihin lumalabas na kung ano yung na-absorb na power nitong R na to by using this circuit here, pareho din yung absorb na power nitong DC circuit na to, kung saan parehas yung R na ginagamit natin. So ito yung representation ng formula nila, no? Yung for the periodic voltage and current, we have this B of t times I of t para dun sa P niya. Pero kapag pure R, yung mismong effective voltage at effective current, yung mismong value ng voltage at current ang sinasubstitute natin. Dito naman may pagka-expression pa. Tapos dito ganun din, may pagka-expression pa rin yung pinag-uusapan natin in terms of I squared R. O in terms of I squared R, parehas din ang pinag-uusapan dyan. Tapos dito naman, average power naman, sa pag-average power, so pumapasok na yung average power natin sa AC na to sa ganitong formula, lumalabas, equal siya sa average power na ganito ring formula, I squared R. Na kung saan I effective or DC, yung DC mismo value yung pinag-usapan natin dyan. Okay? Ngayon, para makuha natin yung halimbawang value ng current o value ng voltage, pwede daw nating ipag-equate itong dalawang ito. No? Okay, so to determine, we have to equate the expression of this average power here for both AC and DC here. So for AC, ito yung average power, di ba? Ayun siya. For DC, ito yung average power. Pag-equate daw natin kasi gusto natin kunin yung effective current here. Tapos, kung anong value niya in terms of, say, maximum. No? So, mag-assume tayo ng sinusoidal current. Tapos gamitin natin itong napalabas nating effective current na to from this relation. So similarly, kung voltage naman, parehas lang naman, papalitan mo lang B ito. No? So B effective formula yon. So yung effective na to, sabi sa atin, parehas lang doon sa sinasabi nating root mean square. Kumbaga, kung voltahe yan, nasa bahay tayo, meron tayong voltmeter, naka-AC siya, i-measure mo yung voltage sa outlet mo. So yung reading mo, yun din yung sinasabi nating root mean square voltage doon sa outlet mo. Hindi effective ang mine-measure natin doon sa mga voltage sa bahay natin. Kundi hindi maximum yun, kundi effective yung voltage na mine-measure natin or may pagka-RMS sila. Ganun ba? No, let's say for example, more or less yung lumabas na reading sa voltmeter mo is 230 volts. So, yun yung sinasabi nating root mean square voltage or effective voltage. Something like that, no? Ayun, mayroon tayong konting derivation dito kung saan sinasabi niya kapag ginamit natin derivation na to na yung maximum value ng current natin kapag daw dinivide natin ng square root of 2, yun yung sinasabi nating effective or RMS value. In terms of voltage naman, kung ito yung gagamitin nating equation na isa-substitute dito tapos in-evaluate natin, ang mapapalabas natin na voltage VRMS natin is Vmax over square root of 2. So parehas lang naman sila, no? Yung current, divide mo ng square root of 2, yung maximum value, yung amplitude, yun yung magsisilbing root mean square value or effective value ng current, same as for the voltage here. So ito yung inassume natin na expression para kay IT, sinabstitute mo dyan, tapos evaluate mo siya. So mapapalabas mong value ni I effective o RMS is Im over square root of 2. Di ba? Kapag sinabi nating sinusoid siya, yung magnitude dito, yung sabi natin, yun ang maximum value ng current. Kapag voltage yung coefficient nitong angle na to, ay cosine na to, yun yung maximum value ng voltage natin. Di ba? So yun ang gagamitin natin, sasubstitute natin dyan. So yung effective or RMS value, ito yung lalabas kay voltage at saka kay current. So, ibig sabihin, mas mataas talaga yung value ni maximum kay effective. Diba? Lumalabas na yung IRMS is 0.707 of isabem or isabem over square root of 2. Something like that. Diba? So, similarly, kung alam mo na halimbawa yung current, so pwede mong kunin yung average power in terms of RMS. Dati kasi sabi natin, average power natin in terms of maximum is I max squared R times 1/2 or 1/2 times I max squared times R. But in here, nawala yung 1/2 kasi nga, sabi natin yung Im natin is square root of 2 times IRMS. So, isasubstitute natin yung Im na to equal to square root of 2 times RMS dun sa formula nating yun na nga, 1/2 Im squared R. So, ang lalabas na doon is, ano na lang, I RMS squared times R. So, similarly, for the average power expressed in terms of voltage and current RMS, magiging ano na lang siya, VRMS, IRMS cosine theta B minus theta I. Previously, in terms of maximum voltage and maximum current, our P average is equal to 1/2 B max, I max, cosine theta B minus theta I. So of course, whether we express our P in terms of max or in terms of effective, if the element we are using is the same, so the answer of the average power then is also the same or equal. Di ba? Parehas lang naman. Iniba lang natin yung forma o yung dating in terms of max yung isa, in terms of RMS. Kahit alin sa dalawa, kung ang pinag-uusapan mo ay same thing lang naman, same resistor lang naman, ang average power ay parehas. Di ba? Okay, ngayon, kung if we have a different frequencies, so sabi natin, yung power natin is equal to yung summation ng power natin. Halimbawa, we have how many frequencies here? We have 3 different frequencies. Then the average power is equal to the sum of those sources with different frequencies. If we have, say, DC source, then the average power total equal to, say, PD, P sub DC, I mean, plus P1 plus P2 up to, say, this P sub N. Ngayon, express natin yung power natin in terms of I and current squares. So this is how we represent our P if we have different frequencies, including this DC. So since we are considering a single value of our load R, halimbawa, say this one R here, then our P will then be equal to this sum of our square of our current different frequencies times R, or R times this current equation. Na? Or, sabi natin, our RMS, if we have different frequencies, is equal to this, including, say, this DC source. Yan. Okay? This RMS, if we substitute here and square it, then will give us the average power absorbed by this resistor having different frequencies. Okay, so we have exercises here. Number 1, we are asked to determine the average value of the given current waveform here. This is the given waveform of our current. And aside from that, we are asked to determine also the average power absorbed dito sa load na to, kung saan ang load na pinabanggit dito, kung saan meron siyang waveform na ganito, ay waveform ng current na ganito ay mayroong 2 ohm resistor. Yan. Kumbaga, meron tayong isang circuit. Yung circuit natin, meron tayong 2 ohm resistor. Tapos yung current na dumadaan dun sa 20 ohm resistor na yon ay may pagkaganitong waveform. Kung titingnan natin, yung isang cycle nitong waveform natin na to ay may dalawang parte. Yung first part natin ito from 0 to 2. Tapos yung second part ng curve niya itong from 2 to 4. So sabi sa atin dito, kapag ginawaran natin ng equation itong from 0 to 2 second, kasi ang time natin dito itong horizontal, vertical, ito yung current I natin. So from 0 to 2, the equation here, if we have 10 maximum value of current there with respect to 2 second here, the corresponding equation then is 5t. Para bang sinabi mong gamitin mo yung slope form, intercept, di ba? Parang ganun yun. So parang shortcut natin yan, 10 over 2, ito siya. 10 over 2 is 5t. Yun. So the time correspond for the half cycle of this waveform is yun nga, from 0 to 2. Then, for the other half cycle, straight line siya. This one, straight line siya. And the value and the equation correspond to the second curve, other half cycle, to complete this waveform here is -10. Ayun siya. -10 is from 2 to 4 second. So, meaning to say, there are 2 corresponding graph with respect to the waveform of our current here. Kasi yung sumunod na waveform is just the repetition of the first. So meaning to say, yung first yung itong from 0 to 4 natin, ito yung magsisilbing waveform nitong current natin. Kasi yung sumunod kamukha lang nung una, kaya ito lang ang gagamitin natin, yung first waveform. Na? Yung first waveform. Yung second waveform kasi is this repetition of the first waveform. So, corresponding to the first waveform, we have a period of 4 seconds. So, yung 4 seconds na yon, respect to our formula here, ito siya. T, yung capital T dito. Yun yung binabanggit na period T dito sa curve na to. So our period T with respect to this waveform here is equal to 4, 0 to 4. So the first half of the waveform, the corresponding time is 2 seconds from 0 to 2, while the second half of the waveform, it's from 2 to 4. It's also 2 seconds. Now, so if combine the total period, of course, the total period is 4. 0 to 2 plus 2 to 4. So 2 plus 2 equal to 4. So that's the period of our given waveform, equal to 4. So if we follow the formula, then we're looking for the effective current as well as the average power. So we can use this formula for us to determine the effective value of our current. So following that formula, this one, 1 over t, square root of 1 over t times the integral from 0 to t of I squared dt. Instead of b squared, we follow this I squared current because It is mentioned that in this problem, the given waveform is a current waveform, not a voltage waveform. That's why our expression here is in current expression. Okay. Then after that, we substitute the first half expression of our waveform. So the expression there is 5t. Okay, 5t. Then we square it. Then we substitute the limit from 0 to 2. Then we add it to the second half of the waveform. And the equation of the second half of the waveform is -10. And we square it. Current, the second part is -10. Substitute here, -10 and square it. Then integrate it from 2 to 4. First, the integral of 5t, of course, is 5t squared is 5 squared is 25. Then the integral of t squared here is t cubed over 3. Ito siya. And the limit is from 0 to 2. For the second half wave, the integral of dt there, the -10 squared is constant. So we can factor out there outside these integral signs. Then we integrate dt. The integral of dt is t. Then we'll have 100t from 2 to 4. The limit is from 2 to 4. So if we substitute the first from 0 to 2, then we'll have 200 over 3. And we substitute this limit with respect to the second, 100t, then we have 200, diba? 100 times 4 minus 100 times 2 is 400 minus 200 equal to 200. So similarly, ganun din, if we substitute this 2 here and subtract by 0, then it will give us 200 over 3. Then after that, add this to 200 and multiply by 1/4 and take the square root, and we give us an 8.165 ampere. So after that, we can use this formula for us to determine the power absorbed by the 2 ohm resistor using I squared R. RMS value of the current is 8.165, square it, then multiply by the given resistor 2, and the answer is 133.3. So this is the power absorbed by the given load resistor, 2 ohm resistor. Okay? And the second one here will correspond to your next activity. So the answer is 2.31. Parang yung equation nito parang ganito rin. Parang 4 over 1, parang 40 from 0 to 1. Then the next one is negative 40 from 1 to 2 second. Tapos ang answer mo dyan, pag finalo yung formulang to, is 2.31. Yun, no? Yung isa positive going upward, yung isa naman, other half is negative. Same equation, kaya lang negative yung pangalawa, yung other half. Tapos ito repetition ng the first. So ibig sabihin, ang period natin dito is 2 seconds, di ba? From 0 to 2. Kasi parehas lang naman ito dun sa percent. Kaya ang period niyo dyan is 2 only, not 4. Okay, we have additional exercises here. Number 1, sabi niya I is 20 cosine 40 plus 30 degrees. We know in this expression, this 20 here is the amplitude, and we know that this amplitude is the maximum value of the current. We call it I sub m. So since we are looking for the RMS value, so we have to divide this 20 by square root of 2. The answer there is 14.14. And in number 2, if we try to compare, they have same frequency, 5t, 5t. Diba? We have W here equal to 5 as well in the second part of this expression. We have also W equal to 5. But since the first one is expressed in positive cosine, so we have to convert this positive cosine, sign rather, into positive cosine. So we need that because we know that in in this second exercise, we have the same frequency. For us to determine the right answer, we have to combine the two expression here. No? So since they have the same frequency, what we did here is we convert the positive sign to cosine for us to combine the first to the second. So the corresponding value or expression of this 10 sign into positive cosine is 10 cosine 5t minus 90. We have to subtract this by 90 to make it positive cosine and add it to the second expression there also in positive cosine. Then after that, since we are looking for the single magnitude, we can express first this into polar form, phasor form. This one, 10 angle negative 90. The second one is 20 angle 30. Combining these two will give us 17.32 angle 0 ampere. So we know that the value of our I here is in maximum expression or value. Since it is in maximum value, so we have to divide the 17.32 by square root of 2. And the answer is 12.24. The next one, try to compare it to the second one. So in here, with even though they have same sign, positive sign for the first and positive cosine for the second, but to try to compare the frequency, the first one here has 5W, while the second expression of our I here is 10. So meaning to say they have different frequency, but in here they have same frequency with different form. But in here, different form also, but with different frequencies. So if that is the case, we have to follow this formula for the root mean square value for us to determine the single value of this expression, RMS single value of this expression. So actually, there's no DC part here, so we can disregard this one. So we have only two. We can use the second and third here. So meaning to say, our IRMS here is equal to, when we follow this formula, we don't need to say convert, say this positive sign to cosine. So kasi ang ginagamit lang natin, we are after lang naman dun sa magnitude, no? Not dun sa sine or cosine form. We are after with the magnitude, after knowing that each expression here ay magkaiba yung frequency. Na? Pag nalaman mo ng different frequency sila, ignore mo na yung kung saan sila na-express, sa cosine ba or sine, basta tingnan mo na lang yung magnitude. Diba? Yung magnitude na lang. Okay? So after that, then we can now follow this formula and substitute it. So 8 over square root of 2, square it, then plus to the second, plus to the effective value of the second one here, we have 6 over square root of 2. Again, square it natin siya. So taking the square of the sum of the square of this, then it will give us an answer equal to 7.07 ampere. Okay, so the next one, also in number 4 here, we have a positive sign and cosine here, but with different frequency naman, because in the first expression of our B here, we have 1W, and for the second one, we have 3W. So meaning to say, we have different frequency here. Okay. So again, following the formula here, our V equal to 6 over square root of 2 squared plus another 6 there over square root of 2 squared. The square of the sum of the square there is equal to 6 volt. And the last one, we have an additional DC source here. So following the value of the DC source here, including the second and third expression of our V here, then our voltage here is equal to the sum of the square. So the DC voltage, hindi na kailangan divide ng square root of 2. DC voltage to eh. No? Don't need to divide this by square root of 2. And the answer is 5.52. Okay. The next lesson, lesson 8 na tayo, no? According to my head, kailangan daw nating bilisan yung discussion natin or magkakaroon daw tayo ng makeup class. Kung maaari, mag-2 sessions tayo per week. Kasi para bang 3 meetings na lang daw tayo. Kung tutuusin, 3 weeks na lang tayo. Baka hindi daw natin matapos. So para matapos natin daw lesson natin, magto-twice a week tayo. So meaning to say, meron tayong para bang remedial class bang tawag doon? Sa Wednesday, same time, no? We'll have a session class on Wednesday, no? Para matapos talaga natin yung lesson natin. Kung i-advance nga pa natin lesson natin, mas maganda kamukha nung dati para activity na lang ang gagawin ninyo. No? Okay. So for the continuation, we have this lesson 8. Actually, isa na lang lesson yun, tapos na tayo eh. Lesson 8, pag nasang lesson 8 is lesson 9, yun na yung final natin. Power factor correction na tayo. Tapos na, no? Di ba? Mas maganda, baka next week tapos na tayo, di ba? O kaya yung next week Monday, tapos na tayo sa lesson natin. Mas maganda yun. Tapos puro ano na lang activity. Yun. Para makapokus kayo sa mga ibang subject ninyo. Okay, lesson 8. Title natin is Apparent Power, Power Factor, and Complex Power. The objective here is to understand the significance of true o yung tinatawag nating real power, tsaka yung reactive power, pati na yung sinasabing apparent power, no? Yung sinusoidal network natin. So we have a definition here for the apparent power. Sabi sa atin dito, this is the product of the RMS value of the voltage and current. So measured in both ampere. So sa DC circuit, di ba sabi natin, pag yung voltage natin, multiply natin kay current, ang tawag natin sa unit niya ay watts. Pero kay AC circuit, yung voltage natin, pag multiply natin kay current, ang tawag natin sa unit niya ay volt ampere. Unit ni voltage is volt, unit ni current is ampere, kaya volt ampere ang lumalabas na unit ng product ng voltage and current natin kay AC circuit. Hindi siya watts. Hindi katulad sa DC, voltage times current is watts. Pero dito hindi. So mas malaki yung product ni voltage kay current doon sa sinasabi nating average power. Na? Okay? So additional ano natin dito definition, itong power factor, ito daw yung ratio ng real or average power to the apparent. Yung real power, yung P-ab, di ba? Tapos itong apparent power, itong S. Yung P-ab over this S, ang kalalabasan, yung tinatawag nating power factor, ito siya. P over S is power factor. Okay, may binanggit siya dito ng formula. Yung una in terms of maximum value. So in terms of maximum value, kailangan natin multiply ng 1/2. If it is in RMS value, so we have to remove that 1/2 because we already convert this BM and IM into their effective value. That's why there's no 1/2 here when we do that. Diba? So actually, these are equivalent with each other. 1/2 BMI cosine theta B minus theta I is also equivalent to BRMS IRMS cosine theta B minus theta I. Di ba? Ngayon, kukunin ko yung cosine theta B minus theta I. So lumalabas equal siya kay P all over BRMS over IRMS there. But BRMS IRMS also equal to S there. Meaning to say, this cosine theta B minus theta I is the corresponding power factor of, say, our circuit. That is equal to P over S. So meaning to say, if we want to determine our power factor, we know our P, we know our S, so we can simply divide the P to the S for us to determine the power factor of the circuit or the whole circuit. And at the same time, this power factor angle theta B minus theta B is also the angle of our impedance. Let's say, for example, we are considering the impedance of our load, and the angle of that impedance will then also equal to this difference of the angle of the voltage and current. Na? Yes. Okay. So after that, we have these 3 elements. So we're going to consider the corresponding power factor of this 3 element here. So sabi sa atin dito, yung power factor natin can range between 0 and 1. So palagi naman yan, hindi lalabas sa 1 yung power factor natin, kahit anong klaseng element siya, kung hindi siya bababa sa 1. Nasa palaging pagitan ng 0 and 1 yung pinag-uusapan natin. Maliban na lang kung pinag-uusapan natin ay pure sila. So kung pure sila, ang power factor natin ay 0 at saka 1 lang naman yon. Pero ideally daw, kapag yung power factor mo ay malapit sa unity, mas maganda yon. Kumbaga sa isang industry, mas nababawasan niya yung bill niya, monthly bill niya. Ngayon kung mataas yung mababa yung power factor, okay, malaki yung losses, so nararagdagan yung babayaran niya. So hangga't maaari, sabi nga sa atin, para mapababa natin yung monthly bill natin, lalo na mayroon tayong business na ganyan, malaki yung kumpanya natin, kailangan natin i-maintain dun sa mataas na power factor. Meron mga ginagamit sila para ma-improve nila yan. Makikita natin yan kung paano ma-improve yung power factor dun sa last lesson natin. Okay, for the meantime, consider muna natin itong tatlong element. If we have a pure sabi natin power factor natin is unity, since for this element, yung angle natin is 0. So meaning to say, if we have a pure yung angle ng theta b natin tsaka theta I is the same. Let's say for example, they have the same angle, 30 degrees, 30 degrees, 30 degrees, so 30 minus 30 equal to 0. So cosine 0 then is 1. So meaning to say, if we have a pure our power factor is 1. If we have a pure L, our factor is 0 and it's lagging, right? Because we know in a pure L, the angle between the voltage and the current is exactly 90 degrees positive. So meaning to say the current I here lags behind the voltage by exactly 90 degrees. That's why we have a what we call cosine 90 degrees here, or power factor equal to 0. 0 lagging. Then after that, yung last one natin, the angle between this voltage and current, theta b minus theta I. This time naman, instead of positive 90, we have this negative 90, meaning to say the current I here leads the voltage V by exactly 90 degrees. So from there, we can simply say that the power factor cosine negative 90 is equal to 0, leading. So importante sa atin dito na alam natin kung leading or lagging yung circuit natin. So tingnan natin yung exercise na to. Exercise number 1. Sabi dito, we have a series connected load and it draws a current I of t equal to 4 cosine 105t plus 10 degrees ampere. When the applied voltage is B of t equal to 120 cosine 105t minus 20 degrees volt. Same omega sila, walang problema, siyempre. So find the average power and the power factor of the load. Also determine the circuit element of this series connected load. When you say determine yung mga element values, kumbaga ang tinutukoy niya yung R, L, or C kaya. Pwedeng RLC combination, pwedeng RL or RC ang combination natin dito. So titingnan natin kung sinong mas predominant, kung bang yung capacitor or yung conductor sa the given circuit na to, given expression ng current tsaka voltage natin, madedetermine natin doon kung may pagka-inductive yung load natin or capacitive. So malalaman natin doon, malalaman natin based doon sa angle nitong current at saka voltage natin. But before that, unahin muna natin yung letter A, yung apparent power. By formula, we know that the formula for the apparent power in terms of RMS is this product. BRMS times RMS, but the current and voltage here are in sinusoidal form. In this form, the magnitude is said to be the maximum value of each expression. Let's say, for instance, for this I of t equal to 4, meaning to say this 4 is the maximum value of the current, I sub m. And similarly, this for BT, this 120 here correspond to the amplitude or the maximum value of the voltage B sub M. So for us to determine the maximum value or rather effective value of the voltage and current. So we have to divide each by square root of 2. Say this voltage Vm, if we divide that by square root of 2, it will give us the RMS. So similarly, if we divide this 4 Im by square root of 2, it will give us this RMS. Then the product then equal to say 240 volt ampere. So this is the corresponding apparent power. Apparent power. This apparent power is of course different from the complex power, even though they have the same unit. Next, yung power factor natin, we know that the power factor is cosine theta b minus theta I, right? Ang angle ng theta b natin is negative 20, same positive cosine here, right? It's positive cosine, so negative 20. So always the difference of the angle here, so negative 20 minus positive 10. So negative 30. Cosine negative 30 is 0.866. So we have to always write this unit, say, for this power factor. 0.866 leading. It is leading because we try to analyze the given angle of each expression here. So we can simply say that this positive 10 is head. And then, itong, yes, okay, itong current na to, ahead siya kay voltage na may negative 20 dito ng 30 degrees. Kaya nga sinabi natin dito na ang power factor natin is leading because we know, based dito sa expression na to, the current here leads the voltage. Na? So, it leads the voltage by an angle of 30 degrees here. That's why we mentioned here that our factor is a leading power factor, say 0.866 leading. So, kailangan natin palaging ilagay ito, leading or lagging, right? Okay, then the last question here is to determine the element values. When say element values, RL or RC. Okay, so to determine the element, we have to consider the this formula. Say Z equal to B over I. So in here, we use the amplitude of 4 and 120 here. When we follow this formula, of course, if we convert those to RMS, we'll get the same Z. Whether we follow BRMS or RMS or B maximum, I maximum, we'll get the same expression for our Z. So we simply follow the maximum value ratio of the voltage and current. And we get this one in rectangular form, say 25.98 minus J 15 ohms. Of course, the real part here correspond to the resistance of our load. And for the other element, we can simply say here, because of this sign here, and at the same time, because of the unit of power factor here, say leading. Okay. So again, for the continuation, since alam na natin kung ano yung element natin because of this sign. Sabi natin, ang element natin dito is capacitor aside from the resistor. So by formula, sabi natin, X sub C is equal to 1 over omega C. And that value is equal to 15 here, right? So we simply follow the absolute value of our X sub C, say 15. So meaning to say, our X sub C equal to 15. And this X sub C is also equal to 1 over omega C. So from there, we can simply say that our C is equal to, say, 1 over the omega there, 105 times 15. And the answer is 212.2 microfarads. So therefore, we can say then that the required element for the load of our circuit here are R equal to 25.98 ohms and C equal to 212.2 microfarad. If so happen kung ang power factor natin dito is lagging, so for us to determine the other element aside from this R, so the corresponding formula then here is X sub L equal to 15. The absolute value of X sub L equal to 15 or say omega L equal to 15. So from there, makukuha ninyo yung L kung ano mang value meron siya in Henry, kaya millihenry, something like that. Na? Okay? So, sandali. Saan na ba tayo? Okay. Meron pa tayong ilang minuto pa. So, 14 minutes. So, itong number 2 na to, parang ano siya, activity, no? Obtain the power factor answer. Activity yan. So, punta na tayo dito sa activity number, exercise number 3. We're looking for the power factor of the entire circuit that sits by the source here. And the average power delivered by the source. Delivered by the source, positive siya. No? Delivered by the source, the average power delivered by the source, not absorbed by the source. There's a word delivered here. So meaning to say, positive yung lalabas dapat na value ng average power natin. Delivered by the source. Okay. For us to determine the power factor of the entire circuit, whole circuit here, we can simplify the circuit by simply considering the total impedance. Diba? We have a series parallel here. And the value of our say here in polar form is 6.99 angle negative 13.24. In rectangular form, ito siya 6.8 minus negative siya. So meaning to say, since negative ang angle natin dito in polar form, negative yung imaginary part ng say natin. So we can simply say here that as a whole, ang power factor natin dito is leading because of the negative sign, the angle of Z, or yung negative sign ng imaginary part ng Z natin. No? Okay. Since we are looking for the power factor, we can simply follow this angle of our Z. As I mentioned a while ago, one way to determine the power factor ay dun sa angle ng Z natin or pwede dun sa angle between the voltage and the current, theta B minus theta I, cosine theta B minus theta I, or dun sa angle ng impedance natin, cosine of the angle of impedance, correspond also to the power factor of our circuit. So, the power factor of our circuit since by the source here is cosine of this, negative 13.24. And the answer is 0.97 leading. If you want, we can also use this formula, cosine theta B minus theta I. What's the angle of our voltage? 0. What's the angle of our current? The angle of our current, try to consider the total current here, I equal to B over Z. Our B is already in RMS, so 30 angle 0 all over. This A here, then it will give us an answer for our I effective or RMS, I mean, is 4.29 angle 13.24. So this is the angle of our current. So if you substitute that, so 0 minus 13.34 is also the same as that. So meaning to say, the cosine of the negative of 13.34 following this formula is the same as this formula. So meaning to say, the power factor is 0.97 leading. Whether we follow this one or follow this angle of our impedance, we'll get the same answer for our power factor. Okay, then once we determine this total current, so we can now consider the formula for the average power delivered by the source equal to positive, not negative. Otherwise, if the question is determine the average power absorbed by the source, the answer there is negative of this. So the formula here is IRMS squared times R. IRMS is this one, 4.29, and the corresponding total resistance natin is 6.8. Not that R 6 or 4. We have to use this R as our total resistance for us to determine the total power delivered by the load, by the source, I mean. Okay. Similarly, we can also follow the other formula for the average power in terms of maximum voltage and current, say BMIM cosine theta B minus theta I. The result is the same, 125. Okay. Actually, the next topic is this one, complex power. We have how many more minutes? We have 9 more minutes. So, sige. Tuloy lang natin, no? Complex power, meron siyang bar sa taas. So, iba siya dun sa sinasabi nating apparent power S na walang bar sa taas. No? So, ang ibig sabihin nitong complex power na to, actually it's also the product of the voltage and current. Kaya lang, sabi niya, product of the voltage RMS phasor and the complex conjugate of RMS current phasor, also measured in volt ampere. Parehas din yung unit. Kaya lang dito, para bang sinasabi natin may pagka tawag dito, may pagka-complex expression siya. Ibig sabihin, pwede natin siyang express in terms of polar, pwede natin siyang express in terms of rectangular. So if we express it in terms of rectangular, ito ang dating niya, S is P plus JQ, or say S angle theta S. Kumbaga para bang kung ikukumpara natin ito dun sa formula ng impedance, yung Z natin correspond to S bar here, tapos yung R correspond to P, tapos yung Q dito correspond to X. No? Yun, parang ganun yun. Kaya lang, power pinag-usapan natin dito. So yung first part dito correspond to the real power, and the imaginary part here correspond to the inductive power. The unit actually here for the inductive power is in bar, either bar capacitive or bar inductive. If the inductive load is predominant here, so the sign correspond to our Q here is positive, otherwise negative ang gamitin natin. If the capacitor is predominant in our circuit, then we'll have a negative Q here. At the same time, we'll have a negative theta S if C is the predominant one here. Okay. So here, sabi niya, the magnitude of the voltage is equal to BRMS here, and expression in polar form, our B here equal to BRMS angle theta B. While for the current, we have IRMS angle theta I. So if we multiply these two, then if we try to conjugate our current here, then the product of these two then will correspond to the complex power S expression. Say for instance, this is our B equal to BRMS angle theta, and this is our current, and we conjugate it. To conjugate our current here, if the sign, the angle of our current is positive, when we conjugate it, we have to change the positive sign of our current angle from positive to negative here. So meaning to say, we conjugate this current I. So change the sign from positive to negative. Then after that, we multiply it. Then we'll have BRMS IRMS angle theta B minus theta I. And if we expand this into two terms, we can do that because expressed in polar form here. If we try to convert it into rectangular, then we'll have BRMS IRMS cosine theta B minus theta I plus J BRMS IRMS sine theta B minus theta I. No? Yes. The first part here will correspond to the real part, P. And the second part of our complex power here correspond to this Q here. We call it the reactive power. active power Q. And by the aid of this power triangle, this P here is the abscissa, and Q here is the ordinate. And from there, we can draw this, what you call this, yung apparent power. Kumbaga yung pinaka-hypotenuse ng right triangle natin, call it the apparent power here. The magnitude of the apparent power here is equal to the square root of P squared plus Q squared. And the angle here is equal to the tangent of Q over P. So meaning to say, if we follow this power triangle, theta S is arctangent of Q over P, and that arctangent of Q over P will correspond to the angle of this expression here of our complex power, complex S bar here. Now, and this one will correspond to the square root of P squared plus J plus Q squared. I mean, na yung value of S here correspond to this one, the value of theta S here correspond to this one. And at the same time, this P here equal to this one, and Q here also equal to this one. This is the imaginary part of our S. The real part of our S correspond to the average power. No? Average power, the RMS cosine theta. So we have only 3 minutes more, I mean. So siguro sige, tuloy natin. May konti pa naman. Yung nga, P is the real or average power measured in watts. Q is the reactive power measured in volt ampere or bar. Reactive volt ampere. Sabi rin dito, if Q equal to 0, so meaning to say, we have a purely resistive load. If Q is greater than 0, then we'll have an inductive load. The L is predominant. And if Q is negative, C is predominant here. Now, if U equals 0, yun. Lumalabas, may pagka-resistive yung load natin. If Q is greater than 0, mas predominant yung value ni L kay C. Tapos naman, mas predominant si C kay L if Q is less than 0. Sabihin, negative siya. No? Also, in a complex power, pwede natin express yung Z natin equal to B over I. We know our B equal to B RMS angle theta B and I equal to I RMS angle theta I. So if we simplify the angle, then we have angle theta B minus theta I. So similarly, we can also follow this formula. The complex power S is I RMS squared times Z, or in terms of voltage and Z equal to B RMS squared over the conjugate of Z. Now, if we are looking for the complete expression of our S here. But if we want to determine the magnitude of S, so we can take the absolute value of this Z here. But if we are looking for the complete expression of our Z, we have to take the conjugate of our Z here. If we follow this formula. But if you follow this formula, hindi na kailangan pag i-conjugate yung current. Diba? Pabalik lang naman siya. Positive. So, we can also express our Z, our S bar in terms of this. This one also equal to P, and this one also equal to our Q. Okay? So, our next meeting will continue our discussion. We're going to discuss the exercise here. Then after that, the last one, yung power factor correction. Then tapos na tayo noon. Tapos magbibigay na lang tayo ng mga activity. Tapos siguro yung final quiz natin. Yun na. Tapos para makita natin kaagad kung ano ba yung kalalabasan ng finals natin as a whole, kabuuan ng grade natin. Kung may kulang pa, pwede naman nating ayusin yung iba pang kulang natin bago tayo magsara. Na? Kasi mahirap na kapag tapos na tayo doon kayo naghahabol, mahirap na maghabol, no? Para mas maganda, habang may time, habol na. Kung may mali akong nailagay sa mga points, no? Kung hindi ko pa nailagay yung mga points nyo sa Campus Plus Plus, sabihin yung sagad sa akin, no? Okay ba? Okay, so hanggang dito na lang tayo. So again, salamat sa inyo. Johnny, salamat sa iyo. No?